Welcome back. In today's class, we are going to be looking at solutions to some real-life examples that can likely be part of the questions that you may be given to solve as students that's offering mathematics, maybe at grade 9 or your SS1 class. We are going to be solving expressional problem first before we migrate to equational problem. Okay, but there are still, after this class, I will still show you several things that will give you some level of confidence to know the reason why number basis is actually very important. I am telling you once again that if there is no technology, your computer, your radio, your TV, any electronics, whatever that we're saying, if they don't exist, it may likely that we don't have all these forms of number basis conversion from here and there. So, but because they exist, we have them. Without any further ado, let's start looking at those questions one by one and begin to solve them. Question number 1. You are given 1110 and 1101 in base 2 to add together. How are you going to do this in base 2? Since the base you are given is not the standard base, which is base 10, so they have to indicate it. Are you getting me? So if they don't indicate to this one as base 2, you either ask your teacher or you say it's not the correct question. But if they want you to do this thing in base 10, you will know that this thing, their addition can be also done in base 10. Are you getting me? Of course, it can be done in base 10. But that one will become if and only if they don't show any base here. But if they want you to do it in any other base, then you can do it in this base. It can be done from base 1 to base 2 to base 3 to base 4, base 6. Are you getting me? It can be done in any base. It can be done in any base. But for clarity, we have to indicate which base if it is not base 10. Okay? So the first one is 0 plus 1. We don't have much time. We have 1. You know 1 is not up to the base, so we write it because it's not up to the base value. 1 plus 0, we also have 1. So what is happening here? This is a kind of switch. Every zeros has become 1. Everything that is off has become on. Then this one should give you a kind of instinct that there is a way that we can turn something that is off to on and something that is on to off if we bring something to it and perform some kind of bitwise operation. But that is not where we're going. So the next one is 1 plus 1, that is 2. Oh, it's off to the base. We are not going to write it completely, so we subtract 2 from it. We left is 0, so we keep 1 because we subtract 2 only one time. Okay, we keep 1 here around this place because we subtract 2 one time. Okay, so the one that we keep, we add it to the next one here. That's make it what? 2. Then plus this one, make it 3. Because it is 3, it is bigger than the base. We subtract the base, we are left with 1. Then we keep 1 also at this point. Okay, so we keep 1 in this from at this point. We also keep 1 at this point. Are you getting me? So what next? We are only left with this one, no any other digit again. So we are going to write this one separately like that behind every number. So this is 110111, which is the answer to the addition. So the next one is subtraction, where we need to take one number that is bigger from the one that is smaller. So let us go. 1 minus 1, that is 0. This is simple. 1 minus 0, 1, and is 0 minus 1. Impossible. We can't do that, you know. Yeah, we can't do that. So for that reason, we will borrow 1 from this place and put it here, okay, and add it to this 0. If we borrow 1 from this place, the value that we actually borrow, it is the value of the base. Whatever that we borrow, we multiply by the value of the base. So we borrow 1, we multiply it by 2. So what happened here is that 2 will be in this place. It will now be 2 minus 1. That will be what? 1. Okay. Since we have borrowed the 1 that is in this place, what we are left with here is 0. And we are having 0 minus 1. Also impossible. Okay. So what do we have? We take 1 from this place and borrow it to this place. That 1 became 2. Okay. It became 2. So 2 minus 1 is also 1. Okay. So at this point here, what we are left with is what? Is 0. And what is here is also 0. So 0 minus 0, we have nothing. So what is here is 1. Okay. That is that for that. So this is our answer in base 2. 1, 0, 1, 1, 1, 0 in base 2. So let us look at the last one. The last one has to do with combination of both plus and minus, okay, before we look at multiplication and division in the next class. So now let us see what this one is going to give us. 1 plus 1, that is 2 minus 1. 1. 1 minus 0 is 0. 1. 0 minus 1, impossible. 1 minus 0. That's what can be done, it's not possible. Hey, for this one, this is plus. Is 0 plus 1, that is 1. Then that 1 minus 0, we are still left with 1. So automatically we are having 1 plus 1, 2 minus 1, 1 here. So what this one is 1. So that is that for that. 1, 1, 1, 1, 1. So this is how everything that has to do with addition and subtraction in base 2 is done. If you look at it, we are applying some basic techniques, which are the basic principles of adding, subtracting, where I need to be, what I need to choose. What are you getting me now? So that is that for that. There is something I really want to show us. So I have been talking about what we call ASCII table. So I want you to look at this particular place here. So this is a standard ASCII table, okay? So it is a table that is one of the fundamental encoding table. Encoding means that you have a character, you represent it in form of numbers. Are you getting me? But the one that is very important that I want to show you is the number from 65, which is the uppercase letter. So the decimal value is 65. If you look at it here, so from the table head, I think we have decimal value, we have hexadecimal value here. Are you getting me? We have hexadecimal value here, we have octal, we have hexa, we have binary representation and the symbols as well. We also have HTML entities encoding of every character. So what is it? What are we talking about is that there are different kinds of encoding. For example, we have uppercase A at position 65, which means that if I spin up a programming language and I do some kind of mathematical computation, I should be able to get letter A. So, but as a programmer, there is two numbers that we learn by heart, and we call them A, the value position for uppercase A, which is 65, and 32. These two numbers enable us to know when to convert a lowercase letter to uppercase letter, and I will demonstrate that using JavaScript. JavaScript can run in browser. Okay, I think I have something that's related to that, but I will show you how to achieve the same goal. Let me reload this page, and so that the console will reload. So if you want to see this, once you just go to your computer, if you have your computer, just press Shift Control plus I. This terminal will open, okay, and you are going to see the list of this menu. Click on console. Okay, if you click on console, this place will open. Just let me clear it. I want to clear it up. Sorry, I want to clear it up. So now if I clear it now, everywhere will be wiped up. So now let us assume that we want to see a particular letter. Okay, so we have, let us assume that we have letter A. If I want to see the value of letter A, I will just say that character encode at, okay, character code at, it will give me the ASCII position of letter A, small letter A. Okay, the question is, who puts that 97 into this computer? How does the computer know that what was paying out is 97? Everything has been encoded, and that table that we are using is called the ASCII table. There is an advanced table aside from ASCII, we call it Unicode, universal code coding table. That one is more expanded, is more advanced, is more complex than the ASCII. I think the maximum value for ASCII is 127. Why for that universal code, I don't even know. It's so copious. Okay, so now for small letter A, it is 97. So if I want to convert it to capital letter A, what I just need to do is to call my string object. Okay, then I will just say that from character code. So I want to place this one into this, because this one will give us 97. Okay, so this one give us 97, so 97 will be passed here, and you are going to see that the small letter A will change to capital letter A. So let us see. Oh, there is syntax error, I can see, because I don't put single quotes before that small letter A. And I will say I want to string dot from character, then I have this. Let me see what is happening, why it's not passing, why it's not giving me this value that I want. Okay, character code at yeah, it should give me my uppercase letter. I didn't know the reason why it's not doing that for me. So but if I do something like 97 here, I think yes, I have 97. Oh, sorry, it skipped my mind. That is it. Okay, I remember right now. Sorry. So what is happening? I will still be getting small letter A. Are you getting me? I will still be getting small letter A because everything that is here is 97. Okay, and the position for like 97 is small letter A. Then if I want to turn this one to uppercase letter, the distance between 97 and 65 is 32. That is to say, if you have a particular small letter, you want to convert it to capital letter, just look for the ASCII number in decimal point and subtract 32. If I subtract 32 from this, so I should be able to get my uppercase. I should be able to get my uppercase. Oh, syntax error, sorry. So I should be able to get my uppercase. Okay, so this is how people who program conversion of lowercase letter to uppercase letter be able to do that. Without this particular ASCII table, you are not going to be able to do so. And we have them in different formats, in Octal, in hexa, in binary, in fact in HTML entities. So for these HTML entities, what is the value of uppercase A? I don't know. Uppercase A is, well, let me see. Oh, it in fact it is the number itself. What you should note about the HTML entities is that it has three major components: this one, and the number. So let me zoom into the browser so that you will see what I'm doing. So yeah, it's big enough. Let us look at I think letter A, 65. So this is 65. What happened? Okay, so that you can see those letters. Okay, this is 65 right now. Okay, the uppercase A, it has three parts: this one, ampersand hash, as well as what, semicolon, and the decimal number of that particular character. Okay, so how do we use this? The people that are using this are those the people that we call UI UX design, front-end engineers, people that use HTML to structure web page. Okay, so if I want to do that, I will have to show you something. Let me just show you what does look like in this place. So I've prepared an index page. This is a file called HTML. This is what we call HTML, the basic structure of HTML. So you can see that the basic structure of the HTML and code entities is this. So then you can put the number within. If I look for 34, what is the value of 34? So for 65, okay, because I want to demonstrate the value for uppercase A, that is for 65, then I will put 65 here. Okay, so I will put 65 here, 65 here. So automatically I will be getting A. So let me try to apply some break tags in between so that they can be separated. Not, I don't want body, I want break tags so that they can be separated. So if I open this one in our browser, I want to open it in our browser, you're gonna see something. So you can see this is, oh sorry, let me just zoom in so that you can see our outputs. So this is it. You can see that this is the basic structure for HTML entities encoding. So in between this is where you are going to put your number. Okay, so this is where you're going to put your number. The first one here is what? Double quote. Then the next one is what? Uppercase A. Which one represent double quote? Let us see the one that represent double quote. Let us see the value. The value for double quote is 34. Let us now go and look for 34 in ASCII table. If you look at 34 in ASCII table, where is it? Let us just go up. Be looking at the decimal value here, please. Be looking at decimal value here so that you can see what we are talking about. We are talking about 34. 34 is here, so this is 34 double quote. Can you see? And that is the HTML entities value. They also have a lot of entities value. These are several encodings. This is the reason why we need to understand that there is a need for us to convert a number from one form to another. We write it in another form is very common in mathematics and we cannot escape it. Thank you for listening. ABP. Please follow to encourage us to do more of this video. We are in the prelim stage, we are in the earlier stage of mathematics, but the students that will likely understand what we'll be doing when we get to advanced are those students that already have the basic knowledge, which are the prerequisite, or the student that is following us. Thank you for listening. ABP.